Hi and welcome to MSc. In this video we're going to be looking at function transformations, specifically translations of functions with asymptotes. So here we have the reciprocal function, and hopefully you can picture what the reciprocal function looks like. I'll graph it for you in a minute, but it does have both a vertical and a horizontal asymptote. Here we have a transformed function g at x, and it is related to f at x via these series of translations. So let's rewrite this now using what we know about f at x. So instead of f at x minus 4, I can write 1 over, and then this x minus 4 goes right in wherever the x is in our function. And then we have the plus 2 that's added on the end. So this is our transformed function. It is a translation of this function. There's been no dilation, like no stretching or compressing, and there's been no reflection of this function. Here we see a 4, and we notice it's still negative. So from that I can infer that the d here is positive, and this means it's going to shift 4 units, and that's going to shift to the right. So because it's a positive d, again, this is kind of opposite land, right where the x is. So we see that x minus 4, we know that actually is a positive d then, and that's going to shift it to the right. We then see the plus 2 here. This tells me that the c value is 2, and that will imply that we're going to have a shift of 2 units up. It's going to shift upwards 2 units. So we're going to take a look here at the graphs of both of these, and then we'll look at how these translations, right and up, alter the location of the asymptotes in this function, f at x. So here are the two graphs. This first one here on the left, this is our f at x function that we had, which was just the reciprocal function. And if we look at this, we could quickly plot the asymptotes. I have an asymptote that runs right along the y-axis, and I have an asymptote that runs right along the x-axis. So we can name our asymptotes as well. This will be our y equals 0. You might even call it the f equals 0 line in this case because we don't have a y defined, although y is quite common for our vertical axis. And then for this vertical line here, we have our x equals 0. Again, the way this works is every point along this asymptote here is f equals 0 or y equals 0, whereas every point along this vertical line is the x equals 0. Notice we have not shifted this. This is just a standard base or parent function. Over in this other one, we do have, this is our transformed g at x curve. And this one is 1 over x minus 4 plus 2. And we can see now that our asymptotes have shifted in this graph. So we have now an asymptote along this line, which I'll identify for you here in a moment, and we have an asymptote along this line. So let's see if we can name these ones. Well, we have along this vertical line here, all points along that are the x equals 4. So this is my x equals 4 line. Notice the grids here go up by 2's. Along this axis here, this is my y equals, or g equals in this case, and I'll put or y equals 2 line. So I have asymptotes along g equals 2, and I have an asymptote along x equals 4. Notice, of course, that we'd already previously identified that the c value was 2. We also had previously identified that the d value here was 4. So notice that the asymptotes shift, the right and left shift. The moving right 4 changes our vertical asymptote to match the d value. So we could even say here that x equals d. And then it also shifts up. We've noted a vertical shift up 2, so we could even say that this is along the line y equals c. And so this will be a common trend on things that have asymptotes when we have translations. The last piece I'd like to add here as practice is a little bit of domain and range work. The domain is the set of x values such that x is an element of the real numbers, and the restriction on x was that x could not equal 0, and that would make the value of the function undefined because x would be 0 in the denominator. On the other graph here, g of x, we have a different restriction. We still have a restriction on the x value. It's an element of the real numbers where x can now not equal 4. And this 4 value, if x is 4, you can see the denominator becomes 0 and the function becomes undefined. But this 4 value is that d value that we saw. So not only does it apply now shifting the asymptote over, but of course that results in the restriction change. Let's look at the range. The range here is the set of f values such that f is an element of the real numbers where f cannot equal 0. Right? So there is no way for this fraction to equal 0. It can approach it but never get there. In this other case here, when we look at the range now, in our transform function, we now have g such that g is an element of the real numbers, and we have where g cannot equal 2, which of course is the equation of our asymptote, but that's also our c value. So we can identify, or by identifying our d and c values, I now know the equations of my asymptotes, and I now know my restrictions. And you'll see this commonly for anything that has asymptotes that's been translated. You'll see this certainly with exponential functions, for example. I hope this run through of asymptotes and translations has been helpful. If it has, please consider liking the video and subscribing to the station. And as always, thank you very much for listening and watching.